So good day, everyone. Today we're going to answer the exercise 1.31 under chapter 1, which is units, physical quantities, and vectors. So this is under section 1.8, components of vectors. So the problem says that you are asked to compute the x and y components of the vectors A, B, and C and D in figures 1, 1E1.28. So that's the problem. Okay, that's what we're going to answer. Okay, so the best way to do this is to make a table. Okay, so say for example, you list all these vectors, B, and vector C, and vector D. Then you write this their magnitude. Okay, magnitude. So for the magnitude for A is 8.0 meter, for B is 15, for C is 12, and for D is 10.0 meters. Then the next one is to find the angle. Okay, what is the angle? It's angle from the positive x-axis to the vector. So angle of the vector, okay, this angle of the vector from the positive x-axis. So let's, for example, for A, so this for A, so this is this angle A. That is theta A. So that theta A, so from the positive is just 270 degrees. So you can list here 270 degrees. Okay. For theta B, so for theta B is just 90 degrees minus 30 degrees. Okay, which is 60 degrees. So you have 60 degrees. Also for theta C, to compute the theta C, okay, theta C is just 180 plus 25 degrees. That's theta C. So 180 plus 25, which is 205 degrees. For theta D, here, for theta D, your theta D is just one, it's just 90, 90 degrees. So 90 degrees from positive X to positive Y plus 53 degrees. So 90 plus 53 degrees, which is 143 degrees. Then you can list all the X components and the Y components of these vectors. Okay. So for example, you want to find the X component AX. Okay, you want to find the X component AX is just a cosine of theta, which is A, which is 8 meters, cosine of 270 degrees, which is 0, because cosine of 270 is 0. So for AY, we have a sine of theta, which is 8 meters, sine of 270 degrees, which is negative 8.0 meter, because sine of 270 is negative 8. If you're going to use these angles, by the way, if you're going to use this angle, such as 270, or the angle from the positive x-axis, you will automatically use cosine for your x component and sine for your y component. So that is the key here. So we have here 0 and negative 8.0 there. So we'll do the same for vector B. For the components of B, we have Bx is we have 15.0 meter, cosine of 60 degrees. So we have 15 cosine of 60. So we have 7.5 meters. Okay, 7.5 meters. So for By, we have 15 meter sine of 60 degrees. So by, our by is also positive. Okay, 15 sine of 60 is 12.99 meter or 13.0 meter. So we put here 12.99 or 13 meters. For letter C, our Cx is 12 cosine of 12 meter cosine of 205 degrees. So we have 12 cosine 205. So negative cosine of 205. So we have negative 10.9 there. So negative because our Cx is in the third quadrant. And we have 12 sine of 205. So we have a negative 5.1. So Cy is 12 meter sine of 205 is negative 5.1 there. Okay. For dx, so we have here negative 10.9 meter, negative 5.1 meter. So for dx, so you have 10 cosine of 143. Okay, so 10 cosine of 143. So 10 cosine of 143. So we have negative 7.99 meters. And for our dy is 10 meters. So we have, don't forget the meters here, sine of 143. So we have 10 sine of 143. So we have 6.02. Okay, we have 6.02 meters. So we have negative 7.99 meters and 6.02 meters. If you add that, you can get the components of your vector sum, and then you can get the magnitudes of the vector and then the angle of the resultant vector name. So 6.02 is negative 7.99. We have 10.9, negative 5.1, and 7.5, 13, or 0, and negative 8. So those are the components, x and y components of these individual vectors. So for more videos like this, please click the like button and subscribe button for more videos like this. So thank you everyone. Thank you for watching.